Welcome everybody, we've been given this question. Sigma k is equal to 1 to infinity negative 1 of k negative 1 divided by k times sigma n is equal to 0 to infinity 1 over k times 2 raised to the power of n positive 1. We are expected to find the sum. Now foremost, what I wish to do is I would like to show you how the sum looks. Right, so let me consider sigma k is equal to 1 to infinity negative 1 raised to the power of k negative 1 over k. Now for k is equal to 1, I would have negative 1 raised to the power of 1 negative 1 divided by 1. For k is equal to 2, negative 1 raised to the power of 2 negative 1 over 2. For k is equal to 3, this is going to be the quantity. For k is equal to 4, this is going to be the quantity. For k is equal to 5, this is going to be the quantity, plus etc. Now I want to show you the pattern. That's the reason I'm taking all the way up to term 5. Now what is this? Negative 1 raised to the power of 1 minus 1. That's negative 1 to the power of 0. Right? And here you have 1. And what do you have here? This is going to be negative 1 raised to the power of 2 minus 1. That's going to be 1 over 2. This is going to be 2 over 3. This is going to be 3 over 4. This is going to be 4 over 5 plus etc. Now this can be further rewritten as negative 1 to the power of 0. That is going to give you 1. And this is going to be giving you negative 1 over 2. This is going to give you positive 1 over 3. This is going to give you negative 1 over 4. And this is going to give you 1 over 5 plus etc. Now what do you exactly see here? You see that the signs are actually alternating. Right. So you start here, you get a even power. Even power means you get a positive. You have a even power, you get a positive. You have a even power here, you get a positive. So 0 to 4, they are all producing us positive. 1, 3, 5, etc. they are giving us negative. So sigma negative 1 raised to the power of k negative 1 over k is an alternating series and of negative, or I would start with say positive 1 and negative 1 for odd and even numbers. Okay, so that is the first observation. So that is the key. With that key we are going to move on. So next what I'm going to do, I'm going to consider all the odd entries. Consider the odd entries. So what are the odd entries we got? We got 1, 1 over 3, 1 over 5 plus etc. So this is product multiplied with the summation n is equal to 0 to infinity 1 over k times 2 raised to the power of n positive 1. Alright. So this can now be rewritten as sigma k is equal to 1 to infinity of 1 over k times sigma n is equal to 0 to infinity of 1 over k times 2 raised to the power of n positive 1 for k odd, such that we are given the field to be as integers. Okay, so that's the reason I'm taking it as z, and not only just z, it's actually positive integers. So this is for the first part. Now let me represent this as odd entries. Okay, as odd. Now similarly consider the even entries. So what are the even entries? Negative 1 over 2, negative 1 over 4, negative 1 over 6, etc. So that's going to be negative 1 over 2, negative 1 over 4, negative 1 over 6 plus etc. Now can I write this as negative of 1 over 2, positive 1 over 4, positive 1 over 6, positive, etc. Yes, I can write this. So now clubbing up with the main series with this is going to be giving us negative sigma 1 over k times sigma n is equal to 0 to infinity of 1 over k times 2 raised to the power of n, positive 1 for k even such that k is element of z plus. Now let me write this as s even. Now since I have a negative sign, I can throw the negative sign over this side and write this as negative s even is equal to sigma 1 over k times sigma n is equal to 0 to infinity 1 over k times 2 raised to the power n positive 1. So two like terms, the only difference between or the splitting edge between these terms is the presence of the negative side, which I have thrown to the other side. So these two quantities or these two summations, say 1 and 2, they add up to give us the main series. So if I were to take this as let capital S be equal to this, then I can rewrite. What can I do? This means my capital S is going to be S odd positive of negative S even. Right, summation of these two. So this can be rewritten as S odd negative S even is equal to S. What I wish to do is I would like to have a slight manipulation of this term. So I want to rewrite this as S odd positive of S even. I need to get a negative S even. So negative 2 times S even. Right. So this is going to be my capital S. So our S even is going to be sigma k is equal to 1 to infinity of 1 over k, sigma n is equal to 0 to infinity of 1 over k times 2 raised to the power of n positive 1. Now what we are going to do is we are going to be applying a small transformation to k and rewrite the series for all terms. You know why? Because in this case k is even and k is element of z plus. The issue is k is even, so we are only restricting the series for k even. What we want to do is we want to generalize it, so that's the reason we are applying the transformation. So I'm going to take let k be equal to 2 times p, where p is element of z plus. So this would mean my S even is going to be sigma p is equal to 1 to infinity of 1 over 2 times p, sigma n is equal to 0 to infinity of 1 over 2 times p times 2 raised to the power of n positive 1. Now let me consider this term. Consider sigma 1 over 2p times 2 raised to the power of n positive 1, where n is equal to 0 to infinity. Now I club the 2 with this, so this is going to be n is equal to 0 to infinity 1 over p times 2 raised to the power of n positive 1, which is going to be sigma n is equal to 0 to infinity 1 over p times 2 raised to the power of, now a times a raised to the power of n. I can rewrite this as a raised to the power of n positive 1 from the law of indices. So it's going to be p times 2 times, or I would say 2 raised to the power of n positive 1 positive 1. Now study the first term of this series. For n is equal to 0, I am going to get p times 2, n is equal to 0, so positive 1. The second term is n is equal to 1, so 1 over p times 2 raised to the power of 1 positive 1, so that's going to be 2 squared positive 1. So this is the first term. Now what I wish to do is I would like to rewrite this as sigma n is equal to 0 to infinity 1 over p times 2 raised to the power of n positive 1. Now just to run the values for n is equal to 0, what do I get? I get 1 over p positive 1. N is equal to 1, what do I get? 1 over p times 2 raised to the power of 1 positive 1. N is equal to 2, what do I get? I get 1 over p times 2 raised to the power of 2 positive 1 plus etc. Now, this is present here. These two are present here in our new series. And then all the terms are going to be present. But there is an additional term of 1 over p positive 1. So, we are actually rewriting this parent in this fashion, but we have an additional of 1 over p positive 1. So I want to get rid of that 1 over p positive 1. Okay, so this is going to be my new S even, provided, because we just considered this term, right? So I'm going to take this as sum A and rewrite this. Hence, we now have A to be rewritten as S even is equal to sigma p is equal to 1 to infinity 1 over 2p times sigma n is equal to 0 to infinity 1 over p times 2 raised to the power of n positive 1 negative 1 over p positive 1. So this is what we have got. Now what I wish to do is I would like to take this 1 over 2 out. So if I were to do that while keeping the picture in the frame, so it's going to be 1 over 2 sigma p is equal to 1 to infinity 1 over p times sigma n is equal to 0 to infinity 1 over p times 2 raised to the power of n positive 1 negative sigma p is equal to 1, this term is coming in, p is equal to 1 to infinity 1 over 2 times p times p positive 1. Okay, now we don't have to touch this because this is exactly the parent that has been given to us. Okay, the original problem is this. Why do I say this? You might be asking me what the original problem was in K and now this is in P. It does not matter, right? It's just a change of the parameter. So that will not affect the form of the series. So you can have P, you can have Q, you can have L. It's going to be same. Okay, having mentioned that, we need to get rid of this. We need to find out what exactly is this. So for that, what I'm going to do is I'm going to consider sigma p is equal to 1. Oh, this is it p? Okay, fine. P is equal to 1 to infinity 1 over. Now this 2p. Okay, so let me just first consider 2p times p positive 1. So we will have to do something about this, right? So we will have to, this is in product, so this is actually a difficult proposition to handle whenever we have product. So we will have to change this. So how do I change this? I'm going to consider this sigma p is equal to 1 to infinity 1 over, I'm going to take 1 over 2 out, and I'm going to rewrite this as a sum of two quantities. So if I have a p positive 1 and a p here, and if I were to take the LCM, I'll have a p positive 1 and I need to get rid of that p, so I place a minus here, so it's going to be 1 1 there, because once we take the LCM, so let me show you that. If I were to take the LCM as p times a p positive 1, this will be p positive 1, this will be negative p. So negative positive goes up, giving us the term that we need, and 1 over 2 is already there. Okay, fair enough. Now let me study this summation. Now for p is equal to 1, okay, I'm going to run p from p is equal to 1 to p is equal to n. So if I were to do that, I'm going to get the first term as 1 negative 1 over 2, second term 1 over 2 to 1 over 2 and 1 over 3, the third term 1 over 3 and 1 over 4, next term 1 over 4 to 1 over 5, etc. And the last term, or I can't say last term, the nth term is going to be 1 over 2. 1 over 2 times the nth term is going to be 1 over n negative 1 over n positive 1, right? Now this and this gets cancelled, this and this gets cancelled, this and this gets cancelled. Finally, when you walk through, this will also get cancelled. So you are left with 1 over 2 of 1 there, followed by n positive 1, right? But this is for any n terms, okay? But we are dealing the variable in p, so this is going to be my p, okay? This is going to be my p. So you take this value, and as you can state that as p is running from 1, we ran p from 1 to some value of n, right? Okay, so probably we can just we don't have to change the variable because we are running the value of p for p is equal to 1 to some n. Now let it be as n. So now coming over here, this is where we need to change. As p is the parent variable, right? So as p is tending to infinity, 1 over 2 times, this is what the sum is produced as, 1 over 2 times of 1 negative 1 over p positive 1. 1 over p positive 1 will tend to 0. So this one will tend to 0. So this will produce us 1 over 2. Okay. So this entire sum will give us a value of 1 over 2 as p is tending to infinity. Okay. So that is for that part. So what I'm going to do is I'm going to take this 1 over 2 and I need to put it over here. So let me take this as some b. So therefore b can be rewritten as, so this is the value of b. So b can be rewritten as 1 over 2 sigma p is equal to 1 to infinity 1 over p, sigma n is equal to 0 to infinity 1 over p times 2 raised to the power of n positive 1 negative 1 over 2. So what is this? What is this quantity? This quantity is nothing but we started with s even. So this is my s even. Now what is this? This is going to be producing us s odd and s even. So I'm going to rewrite that. So this is going to be our s even is going to be 1 over 2 times of s odd plus s even negative 1 over 2. But what exactly we started with, but we know that my s is going to be equal to s odd plus s even negative 2 times of s even. This has been a starting point, right? So what we need to do is we will have to go back and perform the final step. So I'm going to take this as c, and from c we have, I'm going to move this 1 over 2 to the other side. So I have 1 over 2 positive s even is equal to 1 over 2 times of s odd plus s even. Now I'll cross multiply. I'm going to get 2 times of 1 over 2 positive s even is equal to s odd plus s even. Distribute this 2, you get 1 positive 2 times of s even is equal to s odd plus s even. So this is our original system, right? This is our original deductions that we started with. So hence we rewrite s equal to s odd plus s even negative 2 times of s even as s is equal to, in place of s odd plus s even, I'm going to use this. So 1 positive 2 times s even, you already have negative 2 times s even, positive 2 times S even, negative 2 times S even goes up, giving me S is equal to 1. So that is the solution for this question. Thank you everybody. Please like, share and subscribe.